In 1977, humanity launched 2 spacecraft into the void. Not toward a planet, not toward a moon. Into the darkness beyond everything we had ever explored. Their names were Voyager 1 and Voyager 2, and they were never coming back. For decades they traveled, past Jupiter, past Saturn, past Uranus and Neptune, past the last planet, past the last known object, into territory no human-made object had ever entered. And then they reached the edge, and what they found there changed everything scientists thought they knew about the boundary between our solar system and the rest of the universe. Before we go further, if this video makes the solar system feel stranger and more extraordinary than you ever imagined, hit that like button and subscribe to Cosmos Insight. Every subscriber helps us keep exploring the deepest mysteries of the cosmos. Now let's go to the edge. For most of human history, the solar system ended at the last planet. That was the mental model, the sun in the center, the planets in their orbits, and beyond the last planet, empty space, the void between stars. That model was wrong. The solar system does not end at Neptune. It does not end at Pluto. It extends far beyond any planet, far beyond any moon, into a vast, invisible structure that most people have never heard of. The heliosphere. The heliosphere is a bubble, an enormous bubble of charged particles and magnetic field generated by the sun, extending outward in all directions, stretching billions of kilometers beyond the outermost planets. The solar wind, the constant stream of charged particles blasting outward from the sun, inflates this bubble continuously. Every second, the sun pushes the heliosphere outward against the pressure of interstellar space. The heliosphere is the true boundary of the solar system. Not Neptune's orbit, not Pluto, the heliosphere, and it extends roughly 4 times further from the sun than Neptune. This is what Voyager was heading toward. The edge of the bubble. Voyager 1 crossed the boundary first. In 2012, after 35 years of travel, Voyager 1 crossed the heliopause, the outer boundary of the heliosphere, where the solar wind finally stops and interstellar space begins. It became the first human-made object in history to enter interstellar space. Scientists had been waiting for this moment for decades. They had models. They had predictions. They knew approximately where the boundary would be. They thought they knew what Voyager would find. They were wrong about almost everything. The first surprise was the magnetic field. Scientists expected that when Voyager crossed the heliopause, the direction of the magnetic field would change dramatically. Inside the heliosphere, the magnetic field has a specific orientation set by the sun. Outside, in interstellar space, the field should have a completely different direction determined by the galaxy. The crossing of the boundary should have been marked by a sharp change in magnetic field direction. It did not happen. The magnetic field direction barely changed at all when Voyager crossed the heliopause. The field inside the heliosphere and the field outside were nearly parallel. This was not predicted by any model. Scientists had to completely revise their understanding of how the heliosphere interacts with the interstellar medium. The boundary was not a sharp wall between 2 different magnetic environments. It was something far more complex, a region where the sun's magnetic influence and the galaxy's magnetic field were somehow aligned in a way nobody had calculated. This single discovery overturned decades of theoretical work about the structure of the heliosphere. But here's what terrified scientists most. The data that came back from Voyager after it crossed the heliopause showed something nobody had predicted. The density of plasma, charged particles, outside the heliosphere was dramatically higher than any model had suggested. Scientists had expected interstellar space to be nearly empty. A true void, a near-perfect vacuum where particles were vanishingly rare. Instead, Voyager found a plasma environment significantly denser than predicted. Not dense by any human standard, still nearly empty compared to anything on Earth, but far denser than the theoretical models of interstellar space had calculated. This meant that the models of interstellar space that physicists had been working with for decades were fundamentally wrong. The medium through which our solar system moves as it orbits the galaxy, the interstellar medium, was not what anyone thought it was. And if the interstellar medium was denser than expected, that had implications for the heliosphere itself. The heliosphere's shape and size are determined by the balance between the solar wind pressure, pushing outward, and the interstellar medium pressure, pushing inward. If the interstellar medium was denser than the models said, then the forces acting on the heliosphere were different from what anyone had calculated. The heliosphere, the protective bubble that shields the solar system from the most energetic radiation in the galaxy, was not behaving the way the models predicted. And here is where everything changes. Because the heliosphere is not just an interesting astrophysical structure, it is a shield, a planetary shield for the entire solar system. The galaxy is full of cosmic rays, high-energy particles accelerated to near the speed of light by supernovae, black holes, and other violent astrophysical events. These particles fly through the galaxy in all directions. They are extraordinarily energetic. They are capable of penetrating spacecraft electronics, damaging DNA, and over long time scales, affecting the habitability of planetary surfaces. The heliosphere blocks a significant fraction of these galactic cosmic rays. Inside the heliosphere, the solar wind's magnetic field deflects incoming cosmic rays, reducing the flux that reaches the inner solar system and Earth. Without the heliosphere, Earth would be exposed to a significantly higher dose of galactic cosmic radiation. Voyager measured the cosmic ray environment on both sides of the heliopause. Inside the heliosphere, lower cosmic ray flux, partially protected by the solar wind. Outside the heliosphere, dramatically higher cosmic ray flux. The difference was immediate and enormous. Within just a few days of crossing the heliopause, Voyager's instruments registered a spike in cosmic ray intensity that was unmistakable. The heliosphere is real. The protection is real. The difference between inside and outside is real and measurable and large. And the heliosphere is not permanent. The Sun's heliosphere fluctuates. As the Sun goes through its approximately 11-year activity cycle, the strength of the solar wind changes. During solar maximum, when the Sun is most active, the solar wind is stronger and the heliosphere expands. During solar minimum, when the Sun is quieter, the solar wind weakens and the heliosphere contracts. This means the protective bubble around our solar system breathes. It expands and contracts with the Sun's heartbeat. During periods of low solar activity, the heliosphere shrinks slightly, and more galactic cosmic rays penetrate into the inner solar system. But there is a larger concern that Voyager's data brought into sharp focus. The heliosphere's size and shape depend not just on the Sun's output, but on the properties of the interstellar medium the solar system is moving through. As the solar system orbits the galaxy, taking approximately 225 million years to complete one orbit, it passes through different regions of the interstellar medium. Some of those regions are denser than others. Some contain more material, more magnetic field, more pressure. When the solar system passes through a denser region of interstellar space, the heliosphere is compressed. The protective bubble shrinks. More cosmic rays reach the inner planets. The shielding that protects Earth is reduced. Scientists have identified evidence in the geological record that the solar system has passed through particularly dense regions of interstellar space in the past, and some researchers have proposed that these passages correlate with periods of increased cosmic ray flux at Earth and potentially with periods of climate change or mass extinctions. The boundary of the solar system is not just an interesting scientific frontier. It is the edge of Earth's protection. There is something about Voyager's position right now that almost cannot be processed. Voyager 1 is currently more than 23 billion kilometers from the Sun. The signal it sends back to Earth, traveling at the speed of light, takes more than 21 hours to arrive. When engineers at NASA's Jet Propulsion Laboratory send a command to Voyager 1, They wait more than 42 hours for a response. More than a day and a half of waiting, just to know if the command was received. The spacecraft itself is the size of a small car. It is powered by a radioactive decay generator that produces less electricity than a dim light bulb. Its transmitter puts out 23 watts of power, less than a refrigerator light. And yet that 23-watt signal, after traveling 23 billion kilometers through the void, is detected by NASA's Deep Space Network antennas as a signal weaker than 1/10 billionth of a watt. We are listening to a refrigerator light from 23 billion kilometers away. And it is still talking. Voyager 1 carries a gold-plated record containing sounds and images from Earth, greetings in 55 languages, music, natural sounds, the location of our solar system relative to 14 pulsars that could serve as a cosmic address. It was designed to be found, to be played, by whoever or whatever might encounter it drifting through interstellar space in the millions of years to come. Right now, that record is in interstellar space, moving away from the Sun at about 17 kilometers per second. It will never stop. It will drift through the galaxy for billions of years after the Sun has died, after the Earth is gone, after everything we have ever built has been erased. The only thing that will remain is the record and the silence. Here is what stays with you. Voyager crossed the heliopause in 2012. More than a decade of data from interstellar space has now come back to Earth. And with every year of data, the picture becomes more complex. The interstellar medium is not uniform. It is not the simple void that models predicted. It contains structures, filaments, regions of different density and magnetic field orientation. The solar system is moving through this complex medium at approximately 20 kilometers per second, relative to the local interstellar cloud, and we are inside a bubble within that cloud, surrounded by material that is different from the general interstellar medium. We live inside a bubble, inside a cloud, inside a galaxy. And we only know this because two spacecraft launched in 1977, with 1970s computers and instruments kept working for decades, crossed the boundary of the solar system and sent back data that overturned everything scientists thought they knew. The edge of the solar system is real. It has been measured. It has been crossed. And what was found there is stranger than anything the models predicted. Look up at the night sky tonight. The stars you see are in interstellar space. The space between them is not empty. It is filled with plasma and magnetic fields and cosmic rays and the remains of long-dead stars. And somewhere out there, drifting through that interstellar medium, is a small metal spacecraft with a gold record attached to its side. Still going, still transmitting, still listening to the void.